Welcome back to the Hardware Unboxed podcast for episode 55. Today, we have got a special guest joining the show, Intel's Tom Petersen, to discuss everything to do with Intel's Arc Battlemage products, the B580 and the B570. It's a broad-ranging and really interesting discussion that goes into things like how Intel has addressed performance with these products and fixed it in both the driver and hardware level. We're going to be talking about VRAM configurations, why 12 gigabytes is important, pricing differences for VRAM, that sort of thing. We're going to be looking into the die size of the BMG G21 GPU die. Why is it so large compared to NVIDIA and AMD competition? We're going to be talking about the future of Intel's Arc division and whether you as a gamer should invest into something that is a bit dicey as to whether it will continue. And then we wrap things up with a discussion on XeSS 2 frame generation and the new technologies, the software that is supporting these GPUs. So if you're interested in GPU tech, you're interested in upcoming products like Intel's Arc Battlemage, then this is a really interesting discussion, so I hope you enjoy. So on the podcast today, we have a special guest, a rare guest on our podcast. We have got Tom Petersen from Intel. Want to give a quick introduction of what your role is at Intel and what you do?
Sure. My name is Tom Petersen. I'm a fellow in the graphics group at Intel, and I have kind of a double-headed job. Part of my time I spend, kind of communicating outward about what we do, trying to help people understand and appreciate all the different technology that we're developing. And on the other day job is like actually doing engineering work. So I have a small team and we work on advanced graphics technologies, and I help kind of guide us to do great things in the future.
Yeah, I'm sure a lot of our viewers are familiar with some of your work across various other YouTube channels and presentations over the years. So
yeah, it's great to have you now. Decades.
Yes, decades.
Jesus Christ.
Yeah, so it's great to have you on because there's some exciting things to talk about, isn't there? We've just seen the launch of Intel's Battlemage GPUs a couple of days ago, and we're going to be talking about a whole range of different things relating to those products, a lot of things that have come up in questions on our news video and all that sort of thing. But I wanted to start with the journey that has gone on for Intel's Arc GPUs, because a couple of years ago, we obviously got Alchemist with the launch of the A380 in June of 2022. The A770 was sort of the bigger launch in October. And I think it's fair to say there was a bit of a rocky start. Bumpy start. Yeah, the A380 was kind of slipped out a little quietly, and then we got this full launch of products, but then throughout reviews, we obviously saw some features that perhaps weren't up to scratch and ready for prime time, a few driver issues, bugs, those sorts of things.
DX9.
Yeah, that sort of thing for sure. How's everything gone since then? Because Battlemage, we've seen the presentation, it seems much more complete, much more confident. You're ready to go with products, you're talking about pricing, dates, everything ready to go. How's everything shaping up for the launch?
Well, the launch is going really well so far. And, at the end of the day, it really comes down to our game compatibility and can we support the, hundreds of thousands of titles that are out there. And that's been our real challenge with Alchemist when we started, because we're a new architecture. We've scaled up from our integrated technology, but that new architecture has to work with all of those games out there. And I don't know if you know, but just being DX compliant is not enough in this world, because a lot of those games have different shaders that really are not compliant, and they only actually work on the existing hardware platforms. So given that, we've had to kind of work through sort of like a large backlog of compatibility, and we've learned a lot. And now I would say we're not just DX, we're not just DX compatible, we're like industry standard compatible. And that's been a lot of the work over the last several years with Alchemist, and all of that is factored into Battlemage.
So when gamers are downloading like day one drivers or new game drivers, you're saying that's largely what those drivers are addressing? They're going in and working on those, you're just calling them non-compliant sort of DirectX titles. Is it like fixing issues, that sort of thing?
Yeah, sometimes there are things in games that are non-compliant but work on the existing hardware platforms that don't work on us. And obviously we have to fix that. We do that with a collection of techniques. Sometimes it's things like shader replacement, or sometimes our driver just needs to learn a new trick that somebody else has done that we didn't do in our original implementation. Oftentimes it's performance improvements where, there's a particular sequence in the shader that we had not anticipated. And everybody does this. This is not just us, but we're all kind of working on doing the best with whatever the game is doing. And also we have a dev tech team that works directly with the ISVs to try to get ahead of that in the long run. I would say that maybe at this point, the bulk of that compatibility work is behind us. Although on day zero, we do a bunch of testing, and mostly what's happening in day zero is performance improvements, not so much compatibility anymore.
So is that a situation where you do the work for one game engine and that applies across all sorts of other games using the same engine, like Unreal Engine 5, for example, you might only have to optimize that once? Or is it you still have to do it on an individual game basis and there's still broken things in every game?
I would say that in general, when you get really good support for a game engine, you get a lot of leverage out of that, obviously, and not just like trying to fix a game engine, but engage with the game engine developer very early, so that everybody knows what everybody does, and there's lots of QA and co-development. That's our mo. That's the way we like to do work with game engines. But even given that, there's still game specific things that can be either really good for us or really bad for us,
Mm.
and our dev tech team, our engineers are in there all the time, just trying to do the best we can. And sometimes, again, that means reaching out to the developer and saying, hey, this little widget that you did in this shader is not going to work very well for us. So if you could, let us help you, we'll give you code that will make that better on Arc. So it's very much of a broad enablement requirement that we have to do every day.
So in the launch, you talked a lot about the amount of driver updates that you've done, the software improvements. That was one of the big focuses of this announcement. I think there's still a bit of nerves in the gaming community about buying an Arc GPU and the compatibility across a broad variety of games. Like, how far back could you go with your game library? You might have seen our video that we did on Hardware Unboxed where I tested my game library, and most games worked pretty
Yeah,
well.
yeah.
There were obviously a few outliers, but how far back could you go, and what's the sort of compatibility for upcoming titles as well, like the day zero stuff?
Yeah. Well, I would say that if you have a DX9, a DX11, or DX12 title, you should expect them to work on Arc, right? That's our commitment to the gaming community. And if you find a game that doesn't work, we will work hard to make that work on Arc. So it's not like there's a bar that says the top 10 titles only on Arc. That's not the case at all. It's a promise of broad support for DX compliant titles all the way back to DX9. Now, going forward, we have a huge developer relations team and a developer engagement team that's trying to say both advocate the adoption of our new technology, like one of my favorites, XeSS2, which hopefully we'll talk about later. But we're also working on, hey, here's how to code multi-vendor. Here's how to code shaders that are going to be more friendly across all the different vendors, and that's an ongoing effort. But the truth is, everybody wants competition. Everybody
Mm.
wants more people to play in this environment, and they know that we cannot do this by ourselves. We have to have the help of the developer community. We have to have the help of Microsoft, and we got to have end users who are like, "Hey, you know what? I'm going to give it a shot because I want to try something different." And it's just a matter of, I would say, I don't know, forever, as we convince more and more people that we're a more complete, viable solution.
Yeah, I mean, I've been really impressed with the work that the driver team's done because we've sent many reports to you guys
I
over
see
the
copies of
years.
all that. Yes.
Yeah, so we've sent in a few, problematic, driver issues or whatever, especially with Steve's testing suite, because if he's selecting 15 games to test and one of them doesn't work, it's not great for averaging and doing that sort of thing that we tend to do. So, but a lot of those issues have been fixed pretty quickly. I
Oh
think
yeah.
there's only been maybe a couple of titles here and there that have taken perhaps longer than you'd like to see to get the drivers into a workable state. But
Yep.
certainly when I was testing, the A770 across a wide variety of games, I was pretty impressed with how many of the titles ended up working.
Well, I'm happy to hear that.
Especially games that I didn't like. I guess I was expecting newer titles, popular titles to work really well.
Mhm.
But you go back and you play some obscure game in my library, and I was just thinking maybe that's not going to work. But it tended to work pretty well. So what I want to talk about with Battlemage is there's a lot of design changes as well that have gone into certain areas to the hardware that have been improved drastically compared to Alchemist. So when
Yes.
when we're talking about things like game compatibility, how much of that is on the driver side of things, fixing up the code, the incompatibilities that you were talking about, versus some of these significant IP changes that you've made to Battlemage? Where's the sort of balance lying?
That's a great question, Tim. I would say that in general, anything that can be expressed in a shader, And so if you can express it in a shader, then that can be a source of incompatibility if we don't interpret it exactly the same way as the larger established participants do. So SIMD 16, SIMD 32 is a great example of that, where inside of a compute shader, you can actually have an implicit understanding of the data width of SIMD in the architecture that you're running on. And you can code that up and it should work multi-vendor. But the truth is that puts a lot of pressure in different places of our design if we don't have this exact same support that, say, NVIDIA does have as an example. So we've taken that to heart, and now we are supporting SIMD 32. I'm sorry, SIMD 16 natively with a simple emulation for SIMD 32. So say it's like that kind of learning execute indirect is another great example where we've learned from compatibility. This is a much more utilized feature than we expected. That's moved it directly into hardware implementation. So it's that kind of stuff that's over time learning where those critical sort of like IP hardware requirements come from and then adopting. And then, of course, as we make more and more changes to our IP going forward, we now have a huge backlog of both tests and driver tests and micro benchmarks that make it easier for us to stay kind of in that compatibility circle.
So, are some of these hardware changes that you're talking about, is that going to reduce the inconsistency that we might see between games? Because obviously, there's some games that run really well on Arc, and there's others that have struggled compared to similar sort of hardware from your competitors.
Yeah, I would say that in the past on Alchemist, we've had utilization issues where effectively we've got this great sort of compute capability, but kind of getting in the way of ourselves with things that are doing orchestration of the work on into the compute engine. So a lot of that is complex DX things that have been dramatically simplified. So our DX9 driver, as an example, has been rewritten from the ground up. And now you can see already on Alchemist, we're doing way, way, way better performance, like not just like 10%, but like 2x better on DX9. So clearly we had a lot of work to do on the driver side to get to the point where we really wanted to be, which is delivering more efficient use of our hardware platform. And I feel like Battlemage just continues that trend. We're delivering some amazing power numbers. We're delivering really good performance at a smaller configuration than the A750.
Yeah, I mean, that's certainly one of the areas that was very impressive to see with some of those hardware configuration changes. I guess with Alchemist, you're talking about utilization issues and that sort of thing. Did the overall hardware design, with the performance that you were getting out of it, did that fall short of the expectations that you were hoping from that GPU? Like you were hoping it to perform a bit better than it did?
Well, it depends on what period of time you're talking about. Obviously, as we get closer to launch, we have a better understanding of what it is. So certainly by the time we launched, we kind of knew where we were. And that's why, if you remember, there was a series of conversations that I had with Ryan, that I had with even Raja, talking about the hardware potential of the device. And the fact that we weren't really happy with how we were landing it at that moment, but that we were committed to improving things over the next, 6 to 9 months. And that's exactly what we did. So I would say if you go further back in time, like maybe 2 years before launch, clearly we had expectations that were higher because we didn't understand really in detail the inefficiencies of our implementation of the software and hardware, kind of compact.
Mm.
It's not accurate to say it's a hardware problem or a software problem. It's just the combined system was not really ready to scale like we expected. We're coming from an integrated architecture that had a very different constraint, meaning that 99% of the time you are GPU limited. Like your GPUs are so small that if the CPU takes a little bit more work, no big deal because you're waiting around for the GPU anyway. But when we went to Alchemist, that flipped 100%. And all of a sudden, the inefficiencies that were in our implementation came to the fore. So that's really big learning for us over the last couple of years. And I'm very excited about where we are today with Battlemage, though, because the performance is incredible, the per watt's incredible, and we've come a long way.
So has that shortened the, I guess, gap between expectations and the final performance for Battlemage? Like you've been a lot more confident with how it's come out compared to what you were expecting 2 years ago?
Oh yeah, we've invested heavily in both our ability to model silicon early on, our architectural modeling. Also, we're doing a lot more emulation. So we are building these things completely in FPGA kind of emulation environments and running real benchmarks way before we get to silicon. So our infrastructure is now much more modern. Our attention to sort of, let's call it, real game performance versus benchmarks is much higher. That was an early learning as well. We had an early focus on benchmarks, and if you remember, Alchemist did shockingly well on benchmarks, but it didn't really hold that trend when it ran real titles. That was that goes way back to like how did we optimize? We optimized for benchmark, not exactly optimizing for real games, and that's another big mistake that's gotten corrected in Battlemage.
One of the areas that I think a lot of people were really excited to see with the B series was the VRAM. It's because we're seeing a lot of games now, and you mentioned this in the presentation, that are exceeding the standard 8 gigabytes of VRAM
Yeah.
that you would see in the mainstream and mid-range, and
Mm-hmm.
unfortunately even a little higher than that from some other brands, NVIDIA
Yep.
specifically.
Yep.
So a lot of the feedback that we saw in that video was the excitement around a $250 or $249 US product with 12 gigabytes of VRAM and the B570 that has 10 gigabytes of VRAM as well. Was it just a coincidence that the design of this GPU with the 192-bit memory bus enabled this nice 12 gigabyte configuration, or was that something that you'd planned out a while back, that you sort of researched game trends, saw this becoming an issue and went, we need to make sure there's more than 8 gigabytes in this card?
Well, we know that the memory capacity, the amount of memory that games want to consume, has been going up. You can see that. I think I shared a little bit of data about this in the presentation. Also, we know that monitor sizes are increasing. The size of the monitors that gamers is purchasing is clearly moving up to 1440p. So with those two trends behind us, it was pretty clear that above 8 is going to become standard, especially given the lifetime that this card is going to be living, right? If you say right now it's clearly not enough to be 8 and you need to be more like 10 and 12, and that's going to increasingly become true over the next 4 years, which is really my expectation for the lifetime of this card. So happy circumstance. I don't know if I would call it complete chance, but you can look at the data fairly early on and realize you need to be bigger. It is expensive, right? It's not cheap to do larger memory, but it's required to get the experience that we want at 1440p.
It's something that we've heard from as sort of an excuse that some people bring up is the cost that you sort of touched on there, the cost of adding more VRAM, and that would make mainstream GPUs too expensive to go from 8 to 16, too expensive.
Yeah.
That was the thinking there. Is that actually true? Like, does it really cost a significant amount of money to go from, say, an 8 to 12 design or an 8 to 16 gig design?
It does. It does cost because you're talking about not just the memory, which is expensive, but also the interfaces have to run faster. So you're talking about building a bigger chip with wider memory interfaces, which have these little phi things that are like the analog pieces that control the wires. They're pretty big. So having a wider interface running higher frequencies is quite a big deal. Having a bigger capacity memory is more expensive simply because of higher expensive board design and the cost of the actual VRAM itself. So I would say that it is a significantly more expensive proposition to build.
Are we talking $100 though? Because that's what NVIDIA was sort of claiming with the 4080 Ti, 4060 Ti 8 and 16 gig. They were saying, oh, to go from 8 gig to 16 gig, it has to cost $100 US more. Yet with this Intel Arc B580, you're offering 12 gigabytes for $250. So it seems a little hard to reconcile those two stories. So I'm just
Hmm.
trying to figure out which is more
Uh,
the accurate sort of explanation.
I can't comment on NVIDIA's calculation of cost. I know those guys. I love those guys, and I know they're not lying to you. But on the other hand, their calculation is probably very different than my calculation. So it's probably best to
Mhm.
say I don't think it costs that much, but they're probably not lying either.
So was VRAM price a significant consideration with making a card like a B8, B580? You sort of went, we can't really do more than 12 on this card. Obviously, there's the memory bus width
Yeah.
considerations as well, but it seems fairly affordable to get this amount of VRAM for this level of price. It hasn't really happened before. So was it a huge consideration?
It is a consideration of our customers because we know that we're trying to say that we compete well at 1440p, so we have to build an infrastructure to work there, and that has obvious expense issues because we're spending more money on the memory, but we can't raise the price. So
Mm.
as a new entrant, we have to deliver a compelling value. Right? We can't come in and say we're as good as a 4070 or 4060 or 40 whatever. We have to say at a particular price point, this is our benefit. And in exchange for you trying something new, you're going to get a nice benefit. And the benefit right now is you get much better gameplay experience at 1440p because we have a bigger memory and we have wider memory bandwidth, and we have a design that's optimized for that, and we're going to give it to you at a price that you normally will not see in the market where it is today.
Yeah, I think that certainly that is resonating with a lot of people at the moment. The feedback on that has been really good. What are the architectural changes between XE2 design for Arc Battlemage and what we've seen from the Lunar Lake iGPUs? Now, I'm not super familiar with the iGPU side of things from the laptops because don't cover too much of that anymore. But a couple of people were wondering from our audience about those changes.
They're minor. It's mostly the same IP. Obviously, it gets rehardened in a different way. But some examples are it's got a larger L1 cache. So the cache is slightly larger up near the Xe core. And that helps us get a little better, kind of utilization of the Xe core on Battlemage. But for all intents and purposes, the bulk of the logic is reused. And that's very intentional, right? As we start maturing our understanding of how to do this effectively, you cannot do different versions of IP for every chip. And in the past, we've had this sort of feature creep problem where we'll tweak the IP a little bit from gen to gen, from chip to chip, and that is just not sustainable. So you'll see a lot more very firm. This is IP. This is XE3, and XE3 is fixed. It doesn't change per SoC. Similarly, XE2 is largely fixed and probably won't be changing very much per SoC.
So one of the other main differences that we've seen from the Battlemage architecture compared to Alchemist was the shift to TSMC N5 versus N6. A new family of process technology, but there's also been some significant architectural changes. You're quoting things like plus 50% performance per watt improvements, plus 70% performance per core improvements. How much of those improvements is down to the architecture, the architectural changes versus the jump up in process node?
Yeah, that's a good question, Tim. I actually get that quite a bit. It's very hard to tease those two things apart because obviously we only have one chip that we built. But I can point you at one example where we do this thing called micro architectural benchmarks, and I included it in our presentation. You'll see a slide there with a bunch of stack chart, and what that's showing you is core to core comparison of Alchemist versus Battlemage. And in some of those charts, you'll see 12x, 15x on architecture, and a lot of them are 2 or 3x on architecture. And what that's saying is that there were some serious things that needed to be addressed that deliver very high return on investment, that execute indirect, moving into native hardware, SIMD 16, and even improving our ray tracing engine also has direct benefits that are not process related. So I would say, I don't know, but I'm leaning towards heavier architecture than heavier process.
The other thing that I noticed was down to the density of the design. The GPU die has sort of been pointed out as being large for the amount of transistors on that particular process node. So I've got some numbers here. The GPU die BMG G21 is 272 square millimeters. Is that correct? With
I believe that's correct.
19.6 billion transistors. So that's the quoted specs from your die. And we've got some other comparisons here. So 8107 from NVIDIA is 146 square millimeters with a very similar amount of transistors, 18.9 billion. And we also see, I think, Navi 33, 204 square millimeters, 13.3 billion, but that's on TSMC N6. So was there a specific choice made here to make the die not as dense as is possible in that process node?
Yeah, it's a good question. I've actually spent some time with engineering on this because it's come up a few times now. The die, it turns out it's not obvious to say how many transistors you have, because when you build a device, there are dummy transistors that are used both for regularity, because you're often putting down some transistors that are not active in the current design, and sometimes you're putting down blocks and transistors that are meant to be used redundantly, so they're not active either. And then there's also different amounts of caching, which has very different densities. So depending on how much cache you have, how much memory on chip you have, compared to normal logic, you'll get a very different density. With all that said, I don't know how NVIDIA is calculating their number, right? So the transistor count for NVIDIA may be including dummy transistors. It may not. It may be more focused on active transistors rather than dummy transistors. So I think I'm going to have to get back to you when we complete our analysis of what do we think other people are saying. But we're pretty comfortable with our transistor calculation, and that's not including dummy transistors. So ours might be lower if compared to including dummy transistors.
Right. Okay. So you're saying it's potentially a situation of not comparable metrics? I'm guessing the square millimeters is probably fairly comparable because you can measure
that
that.
one you can, yeah, that, but yeah, I didn't even know that this was like ambiguous. I thought it was very clear how many transistors there are, but it turns out that there's actually a bunch of interpretation here that can be applied. And, it might be a good question for NVIDIA, like, hey, how are you calculating your transistors? We'll come back with a statement of how we're calculating our
Mhm.
transistors. And, but I have no idea if that matches what AMD and NVIDIA are.
So I guess if we can't talk about transistors because it's potentially not super accurate, the die design is still much larger than you would
Yeah.
see from 8107. And 8107 is used for the RTX 4060, which is sort of the performance comparison that you're making there.
Yes.
Is it concerning in any sense that the die is so much larger than NVIDIA is able to achieve for not quite the same level of performance, but sort of in the ballpark?
Yeah, I would say let me change it from concerning to it is where we are. So coming
Mm,
from Alchemist to Battlemage, our improvement gen on gen is dramatic, right? Our
yeah,
utilization of cores has gone. I don't know what the right number is, more than 50% better, and that's dramatic for one generation. So
yeah.
if we keep on this trend, then I feel like we are closing the gap with NVIDIA very, very quickly. And that's really what we have to do to be a viable GPU company. It can't be that we're just showing up and being like a little bit bigger or a little bit slower. We have to be at the same class as NVIDIA going forward. And our team is making incredible progress on that front. So I'm pretty comfortable with it. Now that does say, how do you make a business when when your die is bigger? And the truth is, if you look at our profitability, we're not there today. We're definitely not making money on this business yet. It's a longer term investment for us, and it also impacts our integrated graphics product family. So it's like this. We know we're not where we want to be, and we're going to continue to get better on our IP. But in the meantime, we have to acknowledge it, and that means that we're going to not be largely profitable right now, and that's not anything that anybody wants to do.
Yeah, I mean, I think that's a really good point because I guess when we were talking about earlier from Hardware Unboxed side, back in the original Alchemist days, we were saying things like, this isn't going to be something that you can just push out a GPU and then suddenly it's extremely well-rounded and finished and polished right out of the gate. It's going to take many generations to get these designs into a position where they've got all the things that competitors will have.
Yeah,
And so, yeah, at the moment, I guess die size is one of those areas it's had to be a little bit sacrificed compared to
yeah.
other things. But on the other hand, from the charts and things that you've shown, you are using that in a way that's giving a decent level of performance, and it's still you're managing to be relatively price competitive as well.
Yeah, well, I think we're very price competitive, and at the end of the day, that's what you have to do. We as a business have to compete aggressively against the leaders wherever they are, and the fact that our
Mm,
cost structure may be a little bit less, attractive doesn't change that, right? I think I
mhm.
forgot who mentioned it. I think it was a guy I used to work with told me that you cannot set your price. The market sets your price.
Yeah.
All you can do is control your cost. And so that's what we're trying to do. We're trying to make our GPU more and more effective, more and more efficient, which will eventually result in a more profitable business. But that's, we're in a many year journey, and we've gotten better by more than 50% in one generation. I'm very excited about it.
I've got a few other more specific hardware questions about some of the configurations and designs. The first one is the PCI interface being PCI 4.0 times 8. Was there any reason that we haven't seen PCI 5.0 or a times 16 interface? And also, do you think that will cause any performance concerns on people with older systems like PCI 3.0?
So I think the PCIe 4x8 is more than sufficient bandwidth for this class of GPU. So the truth is, right now we don't need PCIe Gen 5 and we don't need by 16, and that just adds more cost if we were to do it. So given our architectural analysis, it didn't make sense. Now there has been some confusion about PCIe Gen 5 because there were some leaks about PCIe Gen 5, but it's very clear where PCIe Gen 4 by 8. There is some technology that's in there that's not turned on, that's not going to be turned on, that has PCI Gen 5 roots. But suffice it to say, it's PCIe Gen 4.
So if you install it on a PCI 3.0 times 8 system, that's going to be still perfectly fine, no
Yep.
issues.
Yep. I would hesitate on a Gen 2, but Gen 3 should be perfectly fine at by 8.
I think if you're on a Gen 2 system, you probably have a few other system bottlenecks in other areas.
Time to upgrade. Time to upgrade. What DDR? Would that be DDR4? I think maybe.
Probably not.
3?
Probably DDR3.
Wow.
I think.
Back in the day.
Quite a way back.
That's more than 10 years back now, right? Maybe 15 years back?
Yeah, it's a long time ago. Certainly before my time covering these sorts of things, I would have thought. With DisplayPort 2.1, we're seeing UHBR 13.5 bandwidth. The maximum spec for DisplayPort 2.1 has a higher class UHBR 20.
Yep.
Is there a reason why that hasn't been implemented? Is it implemented in the GPU design and it's been disabled down to 13.5, or is it just not available?
Not implemented? And again, this goes back to what segment are we participating in? The 13.5 should be more than sufficient for any realistic monitor choice that anybody would have connecting to a GPU at this class. I think, I don't remember the real number right now, but I think it's more like we'll do up to 4K 120 UHD. HDR. So I feel like that is more than sufficient for the current user base.
Yeah, I agree. I mean, obviously, display stream compression is supported.
Yep.
So that means that at least all the monitors that I've tested across a wide variety of products, there's no products I've seen yet that require something like UHBR 20. It's more an optional feature that people like to have this idea that, I don't want to game with DSC or whatever because I'll be able to tell the artifacts or whatever. I don't really think that's
I would say this is that story about, technology is going to migrate down over time. And when you're doing a product design, you're always trying to find, is this something that I need right now because it's going to add cost, it's going to add complexity, or is it really more of a phantom that's not applicable to our market segment? So it's not a feature for us, and it wouldn't deliver any value for our customers. So this is one of those kind of times where it doesn't really quite fit in this segment in our mind.
How much overclocking headroom is available in these parts?
Great question. Well, I should give you my standard overclocking disclaimer where there's no guarantees of any overclocking capability at all, right? We spec all of our parts to be 100% reliable at stock. However, we are very low power. So if you are dealing with an application that's power limited, clearly you can add more power to the design. And the slider does go up to, I think, to like 120% on the power budget. On the clocking, we've seen good results on the samples I've played with. Maybe 200 megahertz is pretty easy, and your mileage will vary. We also have a voltage offset that unlocks higher voltage levels for enthusiasts that really want to get in there and play around. And if you unlock voltage and unlock clocks and unlock power, I think you'll see a nice benefit. Although I don't want to quote any specific results, I think it overclocks pretty nicely.
But I guess you're saying it's not necessarily been designed to be at the absolute hard limit of what that silicon can do. It's
definitely
more
not
of a power concern design.
Yeah, definitely not. I would actually say the top clock, it could be probably higher if we were willing to do more intense, qualification and binning. And so all of that margin that's still left in that design, that's recoverable by end users with overclocking.
Is that the case for the memory as well? I think I've seen some people looking into the actual chips on the board, which I don't know whether that was supposed to be under NDA or not, but people have seen 20 gigabits per second memory when it's actually configured at 19. Is that a potential for overclocking as well?
Yeah, memory overclocking is supported in our utility. We have a new control panel called Intel Graphics Software, IGS, and you can see in there a whole performance panel, and that includes memory overclocking.
Awesome. One of the things we didn't see in the presentation was any performance claims for the B570. So whereabouts is that part expected to land, at least relative to a B580?
Well, you've seen the specs on the size of the B570. So it's a little bit smaller. It's running at a little bit lower clocks. We're not giving detailed performance specs out now. We're going to wait till closer to launch as our add-in board partners bring that chip out in the first part of next year. So B570, look for more data in January.
Okay, fair enough. It looks to be about, I think, like a 10% core count reduction, that sort of thing.
It's right in there, right in there.
So
and the clock's a little bit lower,
So I wanted to move into talking about the price because I think there's been a lot of frustration from mainstream GPUs that this price tier just hasn't received, the love, the attention that we would like to see from AMD and NVIDIA. Did that play into your decision, Intel's decision to launch the B500 series first? Did you sort of see there's a lot of angst in that, that area, and you're just going to give something for those people?
I would say more like we know that to be successful, we have to enter into a market where we can provide a significant benefit. And it's very clear in this 249, and lower price segment that we can deliver a great experience for 1440p gaming, modern new features, ready for AI. I mean, the list of what you can do at this price point is crazy. And so we're trying to make the decisions very easy for gamers that if you want a modern graphics card and your dad's not a millionaire, this is not a bad choice. And at 249, we can really, be significantly competitive.
Yeah, I think so. It seems like a lot of people are willing to try Arc GPUs at some level of discount compared to Radeon or GeForce, and I
Sure.
think that's probably something that you've learned
Get
as
them why they
well.
last. Get them why they last, kids.
Yeah, that's right. So, I mean, Battlemage, it seems to be priced to account for that sort of understanding that people will try it at the right price.
Yeah.
But that seems to be very focused on the current products that we have, the 4060, the 7600. And we know that next generation models from NVIDIA and AMD are going to be launched pretty early next year, probably
Hmm.
CES at January. We're not quite sure when we'll see models from those brands in this tier of price, but
Right.
is the expectation that you'll be still trying to be very aggressive on price once those parts launch? Like you're going to be thinking about, discounts, price cuts, that sort of thing? Or is it sort of you were talking earlier about the margins available on this product. Is this the hard limit for what we'll see for
I
B580?
don't think there's, I think that's a great question. I don't think there's ever a hard limit. At the end of the day, our business team will do the right thing to help clear the market and also to deliver value and in whatever segment we are. So we can't go back and redesign the chip, right? But we can
Yeah.
adjust our position in the market as we need to, and we will. But I would say we have as good a visibility into what's going to happen in the future as you do. And given our estimate of what's happening in the future, this should not need any significant price adjustment.
Did this play into your decision as well to release these products first, like ahead of NVIDIA and AMD?
Yeah, well, I mean, there's two answers there. One is you kind of almost always want to release your product as soon as you can because they're a little bit like fresh fruit. The longer you wait,
Mm.
they start to be sitting on the dock too long. Bananas are no good a week late. So we know that the performance expectation of the market is going up every month, and the longer you wait, you're just kind of
Hmm.
throwing away performance. So, but on the other hand, with Christmas and then CES, and there's lots of launches, you don't want to launch your thing right at the same time as everybody else launching their thing if you can avoid it. So we're very excited to be out in December before all of that busyness happens because that if we didn't make it, it may have pushed us later past all that, which would be a much more difficult time.
And how's supply looking? Like, will you be able to grab one as soon as they're available, or is
I
it going to be
think
sort of a
I hope so. I think so. I kind of can't control all of that. I mean, we can't control all of that. We can control what happens with our reference design, with our limited edition part, which we're making available.
Mhm.
But all the partners have worldwide distribution, and they go on planes and boats and get places. So having retail availability worldwide is our goal on the day of launch. But typically, these things ramp over time, over a couple of weeks.
Okay, well, that's good to hear. Now, maybe the trickiest part of this interview, I guess, or this discussion is talking about future support because I think a lot of people, in addition to what we've been talking about with price and performance and people wanting to take a chance on Intel, is this nervousness that you'll buy an Arc GPU and then the entire GPU division will be cancelled or
Mm.
axed. And there's been rumors, which even for Battlemage, which have been proven incorrect, that Arc is hanging by a thread and has already been cancelled. Is that the case? What are we looking at for the future?
Well, I don't have a crystal ball like anybody else does. Everything can change, but I can say this: that graphics in general are an important part of the PC platform, and graphics are an important part of every CPU today. So, if Intel's going to continue to sell CPUs, we are going to continue to have a need to develop next generation graphics to mate to that CPU core, and these die are increasingly becoming graphics rich. So if you look
Mm.
at the size of these dies, there's less CPU stuff and more graphic stuff. You can look at Lunar Lake to kind of get a sense of how things are shifting. So that trend, I don't think, is slowing down anytime soon. Even CPU cores are becoming more graphics heavy. So with that as a backdrop, the question is, what about discrete? Now, the reason discrete is important is because, well, we're building a new business and we want to be delivering great value to gamers. And it's also the best way to learn quickly about graphics IP. We can iterate it quickly. We can make drivers quickly. We get great feedback. So all of that learning is really invaluable. Now, I think that's the best case I can make for graphics, is that it's necessary for the bigger Intel businesses to be successful. And I do expect to continue to be doing what we're doing. And I'm excited about it because our rate of progress is dramatically faster than it otherwise would have been had we not done discrete. So I feel like we're not going anywhere. But again, anything could happen.
So it sounds like you're saying that a lot of the discrete business is helping out significantly with the iGPU side of things and improving things like drivers and designs and those sort of things. How much has that helped since discrete has come to market?
Dramatically. And now, not only that, I would say it opens up a whole bunch of futures for what does this PC market look like. As CPUs are becoming increasingly competent with GPUs, that's pushing them sort of up in the things that they can do. You can look. Apple has a model where their chips are primarily GPUs with little CPUs attached, and I would say that kind of architecture is very, very aligned with what's happening to user experiences going forward, especially as we get into the era of an AI-enabled PC. There are CPUs, MPUs, and GPUs. Well, those GPUs are very good for large language models, and they're very good for other types of AI processing that you may see become ubiquitous on PCs.
We've seen as well that the CEO of Intel, Pat Gelsinger, recently retired. Whether or not retired is the fully accurate word for that, I'm not 100% sure. But obviously, there's going to be some leadership change at Intel in the next little while. Does that make the future of Arc more or less safe? Is there a bit of uncertainty because of those leadership changes, or is this very much internally like this is a safe business, a safe area that gamers can be confident in?
Well, obviously, I can't predict what's going to happen to the future of Intel or Arc or actually anything, because there's a lot of variability in the world. My sense is, for all the reasons I just walked through, that GPUs are not becoming less important at Intel. They're becoming more important at Intel. And it's critical that we develop the technology rapidly and that we work with our ISV ecosystem partnership effectively. And that kind of says you need discrete. But never say never, and we'll see. But I'm pretty optimistic.
And I guess with Battlemage as well, we've seen just a couple of products launched with the B500 series, and previously you had the 700 series as the top tier products. Is this it for Battlemage, or is there other products that people can be looking for?
Excellent question, Tim. I never comment on future products that haven't been released, so I have no comment on whether there's a next Battlemage or a future discrete GPU.
Well, just have to ask with those sorts of questions, don't you? You have to see what could possibly be happening.
I'm happy to answer. I usually use those questions as an opportunity to talk about whatever's on my mind.
So when it comes to like the plan for Intel Arc long term, is the plan for Intel Arc at the moment just about gaining market share in the discrete GPU market, or is there any other goals that these products are trying to hit?
Well, Arc is right now in an incubation mode, right, where we're trying to learn as much as we can and improve as quickly as we can, and along the way build our brand. So building our brand means we have to have great experiences, we have to deliver value to customers, and we got to be present. We got to be out talking to our friends, talking to the press, and that's where we are. I don't think that's going to change for probably at least one more generation. But you'll see at some point, there's this thing called innovator's dilemma, which you may be familiar with. It's like this whole, how do you enter a new business? This is rare. Intel is not the incumbent here. And the way you enter a new business is you have to deliver in some way, some differentiation. And for right now, we think that's going to be effectively a price performance ratio. And sooner or later, that's going to become so compelling that we'll see a change.
Okay, so it sounds like a lot of the thinking at Intel is based on this sort of long-term plan, as opposed to making cards right now that have got a huge margin so that you can make a lot of money on the cards right now.
Yes, true.
So that's a lot of the thinking at Intel with Arc?
Yeah, well, I think From my perspective, the thinking is Arc is a long-term plan, right? And you know that because the amount of investment that's required to create a new GPU company is extraordinarily expensive. And we wouldn't have started it without kind of a full understanding of what a reasonable expectation is. And it's not a year or two; it's a long term. And we're making good progress. Like I said, 50% improvement gen on gen makes me feel optimistic for how quickly we can close the gap on a per transistor basis with our major competitors.
Mm. And at the moment, it would have to be the case that other like future GPU designs have already been designed at this point because we're
Yes,
already 2-3 years out usually with those sorts of things. So does that
exactly.
mean Celestial, Druid, those sorts of products are on track?
Well, I can't really talk about those future designs. I can talk about the IP a little bit. There's XE3 and XE4, which are the architecture kind of revs that come after
Yeah.
XE2. And XE3 is pretty much done, right? The architect's been working on it for a while. It's kind of wrapped up. Software work is left to be done, but that's going to be making its introduction in the not too distant future. And XE4 is busy, 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 right? They're got their protractors out, they're sharpening their pencils, and they're doing what, architects and engineers do.
And when it comes to AIB support, I guess that's another long-term plan sort of thing that has to be in place is getting more AIBs interested in creating board partner models. And with this launch, you've added a few new board partners, but the main huge AIBs that we see that work with NVIDIA and AMD like MSI, Gigabyte, Asus, they haven't jumped on board just yet. Is there a plan to sort of engage more of these AIBs like those large brands to create ARC products?
Well, of course, we engage with all AIBs, and we are always talking to the leaders as well as all of the new board partners that we're working with. And I would say, from their perspective, they're expecting a certain scale, right? Because they're going to
Mm,
giant factories and giant, marketing machines. And right now, we're still in the building phase, and so it's probably not surprising that we are sort of growing our AIB family. More as we grow together, right? Rather than starting with somebody who, if we're just one design and Jensen says, "Hey, I'll give you half a nickel off of something if this design doesn't reach somewhere," that would be terrible for us, right? So I feel like working with people where we can be a more significant partner with them and they can grow with us is actually the right strategy for right now. And as we start growing in scale, as we're more successful, that will be the trigger for other board partners to join us.
And how much flexibility do AIBs have for designing these cards in terms of things like power limits, clock speeds, other aspects to the design? We know some AIBs are fairly limited by what NVIDIA could do, for example, but what's Intel's sort of limits?
Well, we do have a full overclocking. We don't really call it overclocking. It's AIB differentiation enablement, where they can sort their own chips and they can add frequency offsets, into their firmware
Hmm.
that would allow them to deliver higher clock skews out of the box. And then they would warranty that on their own, and they would have their own kind of guarantees. Similarly, they can build coolers that are bigger and they can raise their power budgets higher. But in this generation, power budgets don't do as much as you might think because the design is already so power efficient that it doesn't really want more power. It doesn't need to go much higher.
Right.
So
Yeah.
I don't think we'll see a lot of those larger power cooler kind of things, although, we'll see them. It's just that the thing that's going to matter the most is this frequency offset differentiation.
All right. The final part of this discussion I want to talk about is some of the software stuff, in particular XeSS, because that's been sort of the crown jewel of the software features that we've seen from Intel. And
Mhm.
certainly every time I've tested it, I've been more and more impressed with the iterations as they've come, especially XeSS 1.3 upscaling, I think is really good. And a lot of people should be using that even on non-Intel products. And with this generation, you're launching FrameGen, which appears to be very similar to DLSS 3 frame generation in its design and how it works. Are there any major differences that you know of in how XSS 3 frame gen has been designed and implemented versus, say, a DLSS 3 frame generation?
That's an excellent question. I will say that I'm very excited about the work the team's done on XeSS 2. Adding FrameGen and XeLL, which is our low latency technology, is a big step forward for us. When I compare it to DLSS 3, the things that jump out at me are, first, we are a pure AI solution, right? There's some traditional work that happens at the front end preparing data, and then there's some work that happens on the back end for composition that's more traditional. But the bulk of what's happening is pretty much all AI. And the cool part is that means that AI has learned how to do optical flow, right? It's not using an optical flow block. It's using a network that has been trained to identify where pixels are moving, which is effectively an optical flow reprojection. And that means it's learned
Mm.
more than just optical flow, right? It's kind of said, in games, how do these pixels tend to move? And if they move like this, where does it mean the middle pixel probably was? So it's learning more than optical flow. It's learning things about acceleration, and it's learning things about, like, maybe light pixels tend to move different from dark pixels. So I love that. It's a pure AI approach. The second thing is it uses XMX technologies. So it's using our systolic array to accelerate the algorithm. And that means that we can make that run well on anything that has XMX, which includes Lunar Lake and Alchemist and Battlemage. So our tech is, it's not like dependent on a specific optical flow hardware, but it is dependent upon an XMX systolic array.
Right, that's a really interesting difference because with NVIDIA, they were talking about how DLSS 3 it has to run on RTX 40 series products because of their quote unquote optical flow accelerator that they added to that hardware. But you're saying that that isn't really a component of this and that you've designed it a little differently in terms of how that optical flow passes works?
Yeah, I would say a lot differently. We
Yeah.
don't have an optical flow block, and optical flow is, it's kind of trying to identify from image to image how do pixels move. So it's a little bit different from thinking about motion vectors, which are like where are objects moving in scenes. This is literally looking at a picture and trying to tell you where has a pixel moved.
Hmm.
And that is a very difficult algorithm to do. And it is very error prone because there's lots of things happening, right? There's occlusion and disocclusion, reflections and shadows, and colors are changing all the time. So to build a block to do that is hard. And NVIDIA's done a good job building an optical flow block. However, AI is pretty darn good. And if you can get an AI block to do that and maybe do a little bit more than that, understanding pixel motion more generically rather than just using this optical flow algorithm, I think we can get better results. And I'm pretty sure we do.
And it looks from the diagram that the UI component is composited at the very end and it
Yes.
doesn't go into this algorithm. Was that a
Yes.
that seems to be a bit different to how some of the other frame generation techs work, where there's either a choice to do it, I think with FSR3 or with DLSS 3, a lot of the games we've seen, the UI kind of goes in and
Schmears.
gets garbled a bit.
Yeah. Yeah.
But is it with XeSS that the UI is fully like a separate sort of pass?
I I I believe we have an option if people want to put it into there as well, and they can smear it if they want to smear it. But we do recommend that people use the API to separate the UI from the kind of reprojected surface.
So does that create a UI that's sort of half rate? Because sometimes we've seen that where obviously the frame generation side may be running at 120 FPS, but then the UI is still 60 FPS. Is that going to be how this works as well?
That would very likely. I would say the interpolating a UI element is particularly difficult, and the reason is because numbers are, you're looking at a UI element which is mostly numbers and letters, and
Mm.
and so what do you say when maybe on the old frame it might say 68, and on the new frame it says 70. So you'd like the middle frame to say 69, right? If you're doing everything
Yeah.
correctly. And that's not interpolating. That's not like interpolating an image to get a 69. You need a different thing. And today, that's a very, very hard problem. I think someday maybe AI could be trained to generate interpolated UI, but it's a big hill to climb, right?
Yeah, it tends to work okay, the half rate UI, but it does depend on the games, or at least games that I've played. Some games have like a really tight masking, I guess, around the UI elements so
Yeah,
that you don't really notice that as much. But then there's other titles where there's sort of this larger area around the UI. So sometimes you'll see the game elements behind the UI are also not being interpolated, I guess. So it kind of
yeah.
creates that weird disconnect.
It is
But I
very
guess
hard.
that's,
Yeah, and it ends up looking a little bit like a shimmer around the UI
yeah.
because you get distortion that is concentrated around the edges of the UI. That's why I really do think the right approach is to do composition for UI. You separate it, basically lift that UI off of the image that you're reprojecting, and then splat it back on top. I don't know if we support this today, but we could do a hinted UI effectively to allow a game to render that interpolated UI separately, right? So the idea would be we would get a first frame and then a second frame. And while we're working on interpolation, it provides us an interpolated UI image. But it
Mm.
wouldn't be interpolated; it would be re-rendered by the game, just
Yep.
that layer. So, this is still very much emerging, and today it's really good, but it's not perfect.
How difficult is it for game developers to integrate the frame generation here for XeSS compared to just the normal upscaling path?
It's very similar. The XeSS2 integration looks very similar to DLSS3. So if you've already done an SDK integration using that first one, the second one is almost free, and that's really cool for us. And that's one of the reasons we followed a lot of the same motifs from that SDK.
So, would you anticipate that there'll be some potential mods there that you'll be able to mod in, like an XeSS2? Because we've seen like DLSS3 to FSR3 pipelines and the reverse of that. Is that a potential here for modders?
I think I don't know the details of what they're doing with those pipelines, but they are very similar. And if you're able to somehow take the call that provides a resource and then
Hmm.
gasket it to the XeSS2 API, that may be sufficient. But I can't really comment until I know the details of it. I think, honestly, Tim, this is an area where the world is calling out for standardization.
Yeah, I
And I've,
agree.
I've, I've mentioned it a bunch of times where this is silly that everybody's got their own SDKs. NVIDIA made an attempt that got halfway there with Streamline. And we were very interested in Streamline when they first talked to us about it. But right now, there's bigger problems that we haven't been able to solve, things like UI, because at the end of the day, we want to do one integration. And whatever that standard integration is, let's just do that standard integration. And then we should be able to provide a DLL underneath of that that's totally independent of the game that implements a particular feature stack. And that has to be discoverable and UI has to work. But that's just such a hard problem that we haven't been able to crack it. But someday I hope Microsoft will do. That's what I'm hoping.
Well, Microsoft has, I guess they've done some limited attempts at this, right? With
Yeah,
some of their
DirectSR is
pipelines. Yep.
DirectSR is a great example. You can kind of say, hey, DirectX is a great example of I've
Yeah.
standardized the way games talk to, and that opened up the whole ecosystem. Same thing for this post thing because I also did a chart that shows AI and AI techniques are becoming much 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 more important in gaming, and
Mm.
because of that, we're now seeing more and more different APIs, more and more different SDKs, and that's not going to slow down. That's just going to increase. So if we can't get ahead of this, what it's going to do is create a fragmented software infrastructure that nobody wants.
Well, it makes it more difficult for game developers because they're having to go through and integrate three, four different technologies. And, you've got your upscaling now, you've got frame generation, and NVIDIA has started with their denoising solution as
Yeah.
well. So that's like a
Yeah.
third thing that
Yeah, and
these developers
XeLL,
have to,
low latency, right? And then there's even
yeah.
there's like a super resolution thing that's different as well. So lots of stuff.
Has there been any thought at Intel to, go down that noise path, like with you see with ray reconstruction? Is there any thought into developing something like that?
Well, we have a research team at in our graphics team that does graphics research, and they talk about all kinds of cool things. Noise is one part of it, but there's many, many other next generation techniques that, there's white papers coming all the time that are so cool. I'm just like, why don't we just do that? And they're like, dude, it
Mm.
takes a little time. So let's not talk about what's coming next. But I think denoising is certainly an area that we can add a lot of value.
Well, I did have one further question about the future, and that is generating more than one frame.
Okay.
So, is this something that is, I guess, possible first off and in the pipeline potentially? Like going from, two, obviously we generate one frame now. Can you generate just an unlimited number of frames, like 10 frames?
Well, it's a great question, Tim. And again, I would harken back to video. So you know that video works with this things called keyframes. And a
Yeah.
keyframe, you can think of the keyframe as it's a full rendered frame. But then every frame after that is a P frame, which is just an
Mm.
update. It's just an update and an update and an update. And they do that for like 10, 15 frames. And you don't know at all that they're not full frames. I think interpolation is similar. The difference is UI. So as gamers are having input, the longer you interpolate, the further the last input was from the screen. And so that's
Mm.
a bit of a problem. And generating multiple internal frames, it's not obvious that that's a better experience until you get new input. So I do think you can. There's no technical reason why you certainly couldn't do two or maybe three. And that would be not hard to do. It would take some work on frame pacing, which we're doing in our driver. So, Alex and his team could definitely do that. It would also take a little bit of work to update our interpolation algorithm. That's certainly not impossible. So I would say it's certainly possible. It's just not clear that it makes it better. You want to make the gaming experience better, and having 3 or 4 interpolated frames may not do that. I do think there's a bigger question here that could make things different. And that is, hey, why am I showing you rendered frames at all? We think about interpolated frames as there was a real frame and then an interpolated frame and then a real frame. So why do you care? You shouldn't really care if it's a real frame or interpolated frame. And that would maybe say, we don't show you real frames at all. Maybe someday real frames are just hints to an AI that is generating you the sequence of images that you see. And that AI might have a different job. It might say, my job is perfect, meaning I'm going to be VSync perfect. I'm going to be as low latency as I possibly can be. I'm going to have never a stutter, never a glitch, and it's glassy the whole time. And so there's lots of different ideas. Once you start saying there's a difference between what a game rastered and what you see, you're into a new area of exploration.
Yeah, it's certainly an interesting thing that we'll be keeping a close eye on in the next couple of years, because obviously there's the latency and the input side of things that you've talked about. And then people, we've heard from commenters this thing of like, oh, there's no need to go to these super, like, why would you bother generating 5 or 6 frames? Because then you're running at 1,000 FPS. Does anyone need 1,000 FPS? But when we've got these high refresh rate monitors, specifically the OLED models coming out at like 480 hertz, and there's pipelines to 1,000 hertz or whatever, if each of the generated frames is a really high quality, it does improve the clarity of the gaming experience. It becomes less of, blurry, kind of like motion blur, and more like a real life experience where motion creates natural blur. And there's research showing how important that is, up to thousands of hertz.
No question. No question. I do think there was a good analysis that Apple did when they did Retina display. And they kind of said, how many pixels can an eye see, right? Because if an eye can't see the pixels, then maybe we don't need them anymore, right? Because having lots of pixels that you only perceive as one dot doesn't do anything. So I feel like there's something about motion that's similar. And the way to think about motion is, as something's moving, it's sort of, your eye is either tracking it or it's smearing across the back of your retina, right? So if things are moving and your eye's not, it's kind of smearing along the back. And so that's what you perceive as real motion blur. Things are moving, but your eye's not. And there's something about how far does your eye have to move as you're showing an image and then another image and then another image. And if you move your eye too much, then your brain goes, that is not real. That is not real. That is a movie. And your brain perceives it as like something's accelerating and deaccelerating really, really quickly. And so I think that's where we are. It's getting to that science, which is, how high a frame rate can I do? And as you get higher frame rates, you're reducing the degrees that your eye has to jump to see motion.
Yeah, and theoretically, with those super high frame rates, there's less need for adaptive sync and those features as well, because the gap between each frame that you're displaying on a monitor is so small that those micro stutters don't become as relevant. So
you're absolutely right.
I'm big on frame generation for improving motion clarity. Obviously, the input things have to be worked through, and XeLL is sort of helping out with that to some degree, as we've seen from other technology. Are there plans to bring something like XeLL to games without the frame gen component? For example, if you had a competitive shooter that maybe wouldn't benefit from frame gen, like Valorant or CSGO, or CS2 now, isn't it? Fortnite. Will we see XeLL on its own in those sorts of games?
Yeah, 100%. I mean, XeLL is an SDK that's implementable on its own. Also, we mentioned that we have a driver low latency mode. So this is something that works with existing titles. You get a significant amount of benefit from it because we drain the render queue effectively, and we're smart about how we do that so we don't lower performance. And that can dramatically lower latency on older titles that nobody wants to like crack open and redevelop on, because the developers are long gone on to the next thing. So yes, XeLL can be implemented isolated from XeFG, and I guess our low latency driver support helps with latency on older titles. I would also mention that XeFG does require XeLL, right? Because we know that XEFG has this latency addition thing because of the interpolation, and XeLL mitigates that.
Mm. So with talking about driver implementations of the low latency side of things, AMD has attempted to do frame generation in the driver with what is it, fluid motion frames,
Yeah.
AFMF or AFMF2. I'm not the biggest fan of that technology, just based on what I've seen. The quality is obviously not as good as you would get from the game implementation of frame generation,
Mhm.
but there are still gamers that seem to be a big fan of using this technology in some games. Is that something that's been a consideration for Intel with their driver team? Let's put frame gen into the driver.
Well, we've looked at it, of course, and we're not opposed to doing that kind of stuff. It's more of a, is the benefit good enough and significant enough to treat that as its own technology? I did a chart during the launch where I showed kind of four quadrants. And on the horizontal axis, you can imagine looking at driver integration, or driver support versus game integration. And on the vertical axis is looking at, like, is it a traditional shader based approach where you're doing sort of like mathematics, or is it an AI based algorithm? And our view right now is that the real growth and the real leverage is in the upper right quadrant, where you're doing both a game integration because you're getting access to all the game information and you're using AI. That is like the nirvana where you can deliver really differentiated experiences. As you start moving away from that, you're trading quality off for easier. You're getting easier access. You get more games because you're not requiring a game integration. That would be like this fluid motion frame thing. Or you're like doing a traditional scalar sort of like GPU architect style human written algorithm, and those are very difficult, very expensive to maintain. So for me, it's all about how quickly can we move AI into different areas of graphic experience.
Is there a risk of integrating frame generation into a driver that, because the experience isn't quite at the level of the game integration technology, that actually makes it worse for the game, if you sort of know what I mean? Like you enable a feature and it's not very good, so it kind of affects your perception of these sort of things. Does that play into it?
It for me it does, because if we enable a feature that's not good, we live with that all the time, right? And we're not in a place
Mm.
where we want to be delivering experiences that we're not proud of. We have to make sure that whatever we're doing is really great, because we're under a lot of scrutiny. Now, it might be someday that we'll have like a beta, like, have, this is a beta. We're not really, it's not done. We're still working on it, and there might be some kind of like beta playbox sometime. But for me right now, game integration is definitely the way to go with frame interpolation. And we're just at the beginning of that, and we're going to continue to make it better.
Do you think as well that there's the risk of, if you have this tool in your driver that could just double the frame rate of all games, that you can then start to market the games using this sort of driver based interpolation? And then you start getting to these discussions of, well, is the quality of that technology comparable to running, you know, the game natively with every frame being quote unquote real? Is that something that you think about with the marketing of these products, like making sure that when you show comparisons across different products, that all the frames are similar or exactly the same? Like where's the threshold that you've got for that at the moment?
Yeah, it's a really good question. And I don't know the answer to that really, because it's such a new problem. It kind of reminds me of VR back in the day. When, if you remember, we were doing some VR benchmarking and trying to separate out. VR doesn't just render, it doesn't just raster, it rasters. And then I think it was, I forgot which company did it, but they did something called space warping, where effectively
Yep.
and that is interpolation, right? And space warping. And then they also have a warp, which is doing that reproduction based on the latest headset. So with VR, we already got into this space of how should we think about these frames that are synthesized? And at the time, I came to the conclusion that, well, we need to identify them, because gamers may not value them as much as a regular frame. And but yet, when you think about the latest warp at the back of the pipeline, that's just sort of a modification of an image. Even though you're not seeing the image that was rendered, it's still a real image, because you have to go through
Mm.
that phase to get on your screen. So it's a very subtle thing, and I think you're going to see the same style of discussion related to frame generation. The good news is we have a tool. It's called Intel Present, and It is the by far the most commonly used backend for doing performance analysis. It's integrated into tools like CapFrameX and Riva Tuner, and it's pretty much the replacement for Fraps. And we can help that accurately reflect the performance. So we are already talking with both AMD and NVIDIA about how should we standardize the way we talk about these generated frames, and how should we standardize the way we talk about latencies? Because today it's all over the map, and we're going to try to make that a little less chaotic.
Yeah, that'd be very helpful because then there's a theoretical path for the future where we replace FPS as a metric, which is very understood and people, they know immediately what that means with more of a latency discussion, which, performance, when we've historically talked about performance and FPS performance, we kind of mean the latency, but we're showing you the FPS
Yeah,
because we've always associated higher FPS, better smoothness, but better input as well. It's much more responsive for your gameplay experience. But now with things like frame generations, that little bit uncoupled, isn't it?
yeah,
Where
yeah,
the FPS shows one thing, but you can increase the FPS but not improve your latency.
yeah.
So
It's a mess. And I do feel like we're going to need help from the reviewer communities, folks like yourself and others, to help guide us into what do you think your readers and your viewers would be most interested in. And we went through this back in the day. I don't know if you remember when we first started doing frame time analysis, and Scott Wasson did some stuff and I did some stuff
yeah.
and Ryan Shrout did some stuff. And it took a long time to get to the point where we all kind of agreed that these are the right things to talk about.
Mm.
And AMD did not like that, right? I remember back in the early days, they got they had a few things that didn't look so good in the new world. And I suspect that same thing's going to happen here, where as we start talking about what's the right new metric and how are we going to standardize this so that people can understand it, there's lots of debate.
Yes, that will continue to be ongoing because unfortunately, FPS, while, I still like FPS as a metric, it is very easily understood by people, and that's why we continue to use it. But it's kind of showing it's getting towards showing its limitations at the
Sure.
moment with these sorts of technologies, and has unfortunate implications for misleading marketing if it's used in the wrong sort of way and you're comparing very different experiences between products.
I totally get it. Well, I think on that stuff, I think you have from us the commitment to be transparent, right? Because this is
Mm,
new, and we want people to enjoy it, which means they have to understand it. And to understand it, you have to be transparent and clear about how are we measuring it, what's happening, and that's why I do this. That's why I'm talking to you, and that's why I talk to others to say, here's what we're doing, and I love it, and I hope you do too.
Yeah, I don't think any of the charts that I've seen have been, especially the performance numbers where you're
Mhm.
comparing the B580 to other products. It's all just normal performance sort of charts. There's
Yeah,
no,
just I say, give me more numbers. Like, let's make it
yeah,
as clear as I can. Because sometimes, marketing guys will just pick a couple of them that are not really indicative. I even show my
mhm,
losses. When we're losing, there's a little, so on my charts, there's always like this little part all the way on the bottom left where I'm like getting my
yeah.
ass kicked. You know how that is.
With the frame generation side of things, how's the frame pacing integrated into sort of XeSS? Because we've seen with FSR3, at least the early days, and I haven't
Mhm.
tested it more recently to know whether they've fixed it, but there were some pretty significant frame pacing issues, especially on some adaptive sync monitors where it was very erratic, especially for panning and things like that.
Yeah.
Not the best experience. How's that work for XeSS frame generation?
Well, I'm pretty excited about XeSS Frame Gen because we do all of the pacing in our driver. There's no back and forth up to some game thread or anything like that. It's all in house, and we can do very accurate timing to put the frame on the screen at the right time. And that works with adaptive sync, fixed refresh rate, VSync modes. There's no caveats about your monitor choice. We'll put the frame on the screen at the right time, or at least we're trying to put the screen on the frame at the, we're probably trying to put this frame on the screen at the right time, and that works down to about, I think the right number is around 100 millisecond accurate. No, I'm sorry, 1 millisecond accuracy. So you'll see the frame, uh, plus or minus less than a millisecond in the middle.
Okay, well, that's good to hear. And you're saying that it works with VSync as well. So if you turn VSync on, it just sort of caps the native render rate of the GPU to half your.
No, no,
fr-
no. What
Uh,
we're trying to do is put the frame on the screen at the best time, and this is related to like the low latency mode and the frame gen stuff. Being aware of VSync helps you know when to start the game thread, especially when you're doing XeLL. So it's not so much like capping at 30; it's more of a more complex related to latency.
But has that meant that, with XeSS2, this is a technology that is exclusive to Intel products, Intel
It is,
GPUs?
yeah, yeah.
Is that part of like the whole pacing of frames thing? Is that part of a reason why XeSS2 is not available or doesn't have a pathway to run on other GPUs?
That's certainly part of it. It's more complex than that, of course, because if you think about it, we need XMX power to be able to do XEFG, which is using a lot of AI to generate frames. And getting access to a systolic array is not really easy in any kind of multi-vendor way. So right now, there's not a obvious path to multi-vendor support for AI technologies that are heavier than, say, what we did with XeSS with our light model for DP4A. DP4A is easily scalable across vendors. XMX and like that systolic array style compute is not. And until that gets much better, there's not a great obvious way that that's going to be multi-vendor.
So is it a case where just the quality loss to do it in a multi-vendor way was too great relative to the version on Intel that you just couldn't justify it?
Yeah, we need the performance that comes from systolic to do a good job of AI based frame generation. And there's not a window that we have today that would get us to a smaller model with acceptable quality.
And what's the sort of performance cost of the frame generation technology? Because it has to do something on the GPU to generate those frames.
Yeah.
So how much does that affect the sort of, I guess, the native render rate of the
Uh-huh.
game compared to running it without frame generation enabled? So your
Yeah.
FPS will go up, right? But we're talking by how much
Yeah.
effectively?
That's a very interesting question because if you imagine a couple cases, let's say that you are 100% GPU limited. And then your frame rate is now this is also kind of complicated. I guess that's going to get too complicated because depending on what your frame rate is, you can be very high frame rate with being GPU limited, or you can be very low frame rate with GPU limited.
Hmm.
If you're very low frame rate, that means basically the CPU does very little, and then there's a lot of GPU. With that environment, we can do just a little bit more GPU and double your frame rate, and you're going to be way better off. And we'll pace those frames to give you that middle frame at the right time. Now, if you're running very high frame rates and you're still GPU limited, then doing interpolation is not going to help you very much, right? Because you're replacing the interpolation work with you're replacing the real render work with interpolation, and you're actually lowering your real render rate by inserting an interpolation in there. But that's in general not the case. In general, when you're doing interpolation, you're on that moment where the GPU is very big or the CPU is very big, and your frame rates are relatively low. As you get to higher frame rates natively, then there's less benefit and maybe even a downside from interpolation.
So what's the minimum frame rate that you would recommend using XeSS2 with, before you enable frame generation? 'Cause
Ooh, I
We've
don't
seen
have
some
a
consoles
yeah.
unfortunately do like 30 to 60,
Uh
which
huh.
not ideal, but so
Uh
what's the
huh.
minimum?
I think 30 to 60 is definitely okay. You'll see pretty good results from 30 to 60. I think 45 and up is better baseline. But it's still very early for us looking at games coming from XeSS2. So I don't think I'm ready to make a real, global pronouncement. But those are the rough numbers. Below 30, definitely not great because your latency is still so big that you're going to feel it even with XeLL, which is not going to be.
Okay, well, it's been a very interesting discussion talking about XeSS because I find these technologies very interesting. There's obviously a lot of, I guess, the newer stuff that we've seen from graphics. The performance side of things has been slowing over time from other brands in particular, and now there's all this talk about these sort of technologies, XeSS. What are we doing with upscaling and frame generation and those sort of things? So is this where you're going to continue to see games integrating more and more of these sorts of technologies, more super resolution, more amounts of upscaling, that sort of thing?
100%. 100%. Yeah, the way to think about it is this goes back to the big trend that we're all experiencing, this once in a lifetime thing that is the adoption of AI through every aspect of your life.
Mhm.
And gaming is no different. I mean, we're right at the very beginning of games becoming AI first, and render is just a great example of how that's. We're in a hybrid mode right now, where there's raster happening, and then there's AI happening, and they're both cooperating together to generate the final image. It doesn't have to stay that way, though. If you look at generative AI, it's now taking text and generating pictures and taking words and generating music. I mean, AI can do very good jobs of generating anything. And so the question is, what does the future of content creation and generation look like in the world of AI enabled technologies? And I don't know, but it's definitely not staying where it is. Where we are is just the beginning, and we're in a hybrid mode, becoming who knows what.
And how does ray tracing fit into this picture? It's probably a good way to finish up this discussion, because the B580, it can do ray tracing, and you've shown performance charts compared to the 4060 and 7600 in ray tracing, and even shown how if you're upgrading from a GTX product, you get ray tracing for the first
Yes.
time. But
How'd you
what
like
is
that
this?
chart? What'd you think of that chart? Is that too much?
Well, it's true. It's true. I guess with ray tracing, like how much can the B580 realistically do in terms of its ray tracing performance?
It's got good performance for ray tracing, but here's the thing that's most interesting. When you come back to this XeSS2 discussion, you'll realize that the amount of energy you spend generating the base frame, and let's call that a heavily ray traced frame, can be very expensive because you're not going to spend that twice. You spend that once, and then you use generation, which is now taking that high quality image and just doing interpolation on it. So that makes interpolation even more important. So I feel like what you're going to see is turning up the visual quality of that rendered frame and then seeing the benefit manifest in terms of frame rate from interpolation.
Okay, so I guess you're suggesting that for like a mainstream gamer to use ray tracing on this card, you're probably going to have to enable a lot of these features and technologies. Um, but you are quoting that it is quite a bit more powerful than a 4060 for ray tracing. I think
It is.
25% more powerful. And there's always been that sort of like, where's the threshold of cards being either good enough for ray tracing, like really capable of it, like a high tier product, versus
Mhm.
not quite good enough? And certainly for a lot of mainstream entry level products, they've been very much too slow to run ray tracing.
Yes.
Can the B580 do like, where's the limit? Is it like minimum level ray tracing effects, path tracing? Is that possible?
Well,
Where are
I look at
things?
that's a very good question, Tim, and there's lots of ways to answer that. Let's start with ray tracing engines, meaning game developers and engines are getting way better at using ray tracing. So they're not, in the beginning, things were a little naive, maybe tracing a lot more pixels than needed to be traced. Like if you're doing reflections, don't trace pixels on things that don't reflect, you know?
Yeah.
So there's lots of that, just learning about how to use ray tracing, and different effects are being evolved all the time that are now ray tracing oriented effects that just didn't exist before, and they're being designed with the hardware in mind. So you know, kind of like, what's the budget of the hardware that I have. The second thing is, I've already mentioned this AI based upscaling is making ray tracing more accessible and more useful than prior to that technology. So I think that's a big inflection point where you're seeing, maybe I don't need to think about ray tracing as like dampening my overall experience. It's, I now have the budget to turn it on because I'm only running ray tracing every other frame. So that's a lot of change. Like the what is ray tracing is different now in terms of what the workloads are, and how are we using ray tracing, given the upscaling and XeSS2 style technologies is different.
From what you've seen from your research, are we moving into more games that will just have ray tracing paths? I think, what was it? It just came out,
Only ray
right?
tracing?
Indiana Jones is a game, right, that only uses a ray tracing path. Things like
Mm.
Star Wars Outlaws, those sorts of games. Is this coming quicker than we're thinking? Like more games in the next couple of years are going to be these only ray traced versions?
Wow, actually was not aware of that. I think that's going to be the exception rather than the rule for a while, given the installed base. And you know how
Hmm.
software developers are all about, hey, I want to sell this title to a lot of people, so I need a big installed base. But over time, I mean, this technology is going to become present on all rendering platforms, and it's going to get increasingly good and increasingly faster. And who knows, maybe we'll invent a better, a better basic algorithm now that ray tracing is sort of first tier development. So I don't think it's going to replace render or raster for a while, um, but it's certainly now taking on more and more significant roles with path tracing and global illumination, and it's probably just the beginning.
Yeah, I think Indiana Jones doesn't even load if you don't have hardware accelerated ray tracing
I didn't know
capabilities
that.
in your GPU. So
Uh,
I think Star Wars Outlaws, it will run on some fallback path if you're using an older GPU, but
mhm.
I believe with Indiana Jones it just doesn't let you use it at all. So
Wow.
it's certainly a unique title, probably the first one that we've seen with that sort of
I'm
consideration.
curious.
But
I'm gonna go look it up. I honestly I didn't even know that. That's great.
okay, well, thank you very much, Tom, for joining us on the podcast. We had a lot of discussion about these new Battlemage products, and you will see the reviews of these later this week because
Oh,
the
very
launch is
exciting.
coming up in just a few days.
Very
So it's
excited.
very
Very
exciting.
excited. Oh my gosh. Well, thank you very much for having me. This is my first time talking. I think this is my first time doing a podcast with you. Is that right?
That's right. Yeah, we haven't had too many guests on the podcast. Want to do some more guest appearances. So it's been great to have you on to chat about these new Arc products because there's just so much excitement about them, I think. And yeah, really keen to see how Steve's review goes in the next couple of days.
Yeah, and I would just like to give you some positive feedback. You were a fantastic interviewer. So good job. I felt like we're just having a conversation. It's great.
Oh, thanks. Yeah, don't do too many interviews, so it's always a bit daunting, but
You did great.
it's
You did
going
great.
okay. All right,
Yeah.
well, thanks very much, and yeah, we'll take a break here on the podcast and do a little intro later. And that does it for today's Hardware Unboxed podcast episode. A big thank you to Intel's Tom Petersen for joining to discuss everything to do with Arc Battlemage and the new Arc B580. We'll have our review of the B580 in the next couple of days. Steve is hard at work at that right now. The reason why I wasn't on this podcast is actually because he's got a bit of a sore throat. So best wishes to Steve in his recovery from his lost voice. Just, yeah, couldn't unfortunately come onto this podcast, but hopefully you enjoyed Tom Petersen filling in for Steve a little bit on this one with a lot of interesting topics discussed. As always, if you want to support the Hardware Unboxed podcast, then you can do so just by subscribing to our YouTube channel, the Hardware Unboxed podcast. You get the video version of this episode if you really want to. Most of it is just standard audio stuff, but if you really want the video version, it's available on the YouTube channel. We also have the audio version available through the usual feeds, Spotify, that sort of thing. So, yeah, thanks for listening to this one. If you enjoy having guests on our show, on this podcast sort of format, then please let us know because we'll try and organize a few more guests in the future if you do enjoy hearing from interesting people in the industry who have a lot of experience with these topics. So, thanks for listening, and I'll catch you in the next one.